Dear student, in today's video, we are going to see one of the type of the ensemble learning, that is bagging. Now, in last video, we have seen what do you mean by ensemble learning. Now, what are the types of the ensemble learning? One of the type is bagging, another one is boosting, and the third one is stacking. Okay. Now, as you can see in the diagram that bagging is indicating the parallel execution, while the boosting is indicating the sequential execution. Means what? In both bagging and boosting, you will divide your data. Okay, you are going to divide the data set into subset. But in bagging, what is happening? One of the subset will be given to one model. At the same time, the subset 2 will be given to the second model. Means all these models are being executed in parallel to each other. Okay. Then finally, to aggregate their performance, to aggregate their prediction, we will use majority voting. So this is what bagging is following. Now, in boosting, what we are doing, our whole data will be passed to the model 1, that is to one algorithm. Now, whatever is the output, that output we are not satisfied. So, it is weakly trained algorithm, that is a weak learner. Then again, that output will be given as an input to the next model. Okay, so like that, one after another we are performing in boosting. Okay, now, as you can see in the diagram, in bagging, our data will be inputted. The data you are given to divide into the batches. Okay, so this division is known as the step 1 of your bagging, that is the bootstrap. Then each of this batch, that is the subset of your data, should be feeded to the model. Okay, all these models are working in parallel. And then finally, whatever is their prediction, that should be combined together. And that step is known as the step 2 of your bagging, that is the aggregation. And generally here we are using majority voting as an aggregation step. Okay. And finally, with the majority voting, whatever output you have obtained, that we will give as a output of your bagged model. Okay. Now, as I told you, there will be two steps in bagging. First one is a bootstrapping, in which data should be divided into batches. Then the next step will be aggregation, in which we are going to combine the predictions generated by each of our model by parallel execution. Okay. So, bagging is used to reduce the variance, while boosting is used to reduce the bias. Understood how ensemble learning is capable of achieving low bias and low variance by each of its type. Bagging is used to reduce the variance, while boosting is used to reduce the bias. Now, as I told you, your data D will be divided into subsets. Then that will be given to the model MI. And finally, that M will be multiplied with the count of votes because we want to go for majority voting, and the aggregation of all the prediction is performed to get the final prediction. Now, how is your algorithm? The first one is you want the subset with equal tuples. So whatever is a subset of your data or batch of data that is containing equal number of the tuples. Okay, then execute each model on these tuples. That is a parallel execution. And the final prediction you are doing by applying the majority voting. So the first step is your bootstrapping. This is the execution step. And the last step is the aggregation. So your bagged model is having two main steps, bootstrapping and aggregation. So how is our bagging? Divide original data set into the subsets, then execute them parallelly, and finally have the combined prediction. Okay. Now, random forest. Random forest is a very good example of bagging. It is a bagged ensemble learning. Okay. Now here, what is happening? We are dividing our data. Means the dimensions will be divided. Means columns, features will be divided. Then out of these features, each feature will act as a root of your decision tree. And finally, what we will do, we will combine whatever are the prediction of each decision tree. Okay, like this. Your data set will be divided randomly so that random number of columns will be divided into the subsets of the data. Then out of these random columns, one will be selected as a root of the decision tree by applying your ASM, that is the attribute selection measure, that is the entropy and information gain. And then you are going to develop your decision tree. And finally, whatever are the predictions of this decision tree, those will be aggregated together by applying the majority voting. Okay. Now, implementation of the random forest. You have your original data. Now, I want subset of that data. Then for that purpose, the subset of the features should be selected randomly. Means it is not the case that the first three columns will belong to the subset one. It is not the case. Randomly columns will be picked up and they will be part of your subset. Then out of available columns in that subset, you will select the best split. Okay, means that will be the root of your decision tree. Then you will repeat this procedure iteratively unless and until your tree has been grown to largest. Means the point where further division is not possible, you have reached to the leaf nodes of your decision tree, you will go on repeating this process. Then what you will do, you will aggregate the prediction of n number of the trees to get the final prediction of your random forest. So what are the advantages? Whatever may be the number of columns in your data set, means whatever may be the dimensionality of your data set, random forest is performing efficiently. And suppose you are having any missing quantities, any data is missing, then also the accuracy of random forest is not affected. But what is the disadvantage of it? It does not work well for regression. It will perform well for classification. Okay. Now, where you are going to use bagging. In IT sector, where you want to reduce the attack on your data. That is a network intrusion detection. Okay, there you want to improve the accuracy. Then in environment means whatever data you are getting from satellite, that should reach to you without errors, with high accuracy. Then in finance, of course, in fraud detection, in credit risk reviews, etc. And in healthcare, where you want to predict the type of the disease, there you are going to use the bagging. So what we have learned in this video is what do you mean by bagging? What are the 2 steps in bagging? Then how random forest is implemented, and finally how we are achieving the prediction in random forest, and what are the applications of bagging. So in next video, we will see remaining 2 types, that is boosting and stacking. Thank you.